Every year, Americans put on 14,000 firework displays across the country for three reasons. 1, to have fun, 2, for holidays, and 3, for things like this. When watching these fireworks, you may start to wonder about the chemistry behind how the different colors are produced and how our eyes are able to perceive them. However, before we answer these questions, we have to understand how fireworks work. When the lift charge detonates and a combustion reaction occurs, the main fuse is lit. The main fuse, however, acts as a timer. Both of these two components are held inside of the launch tube, which aims and directs the shell upwards. The shell is made up of 3 parts, the first of which is black powder, or a mixture of sulfur, charcoal, and potassium nitrate, which breaks apart the shell after the fuse is burnt through. Stars, when unlit, are dull and boring in appearance, but when lit, they can result in beautiful flashes of color and light. The last part of the shell is the time delay fuse, which ignites the black powder and releases colored stars in almost every direction. What remains at the top of the firework is the break, which is filled with black powder in order to make sure the colored stars are able to make an appearance on the outside of the rocket. Other than black powder, other compounds are added like binding paste, which is mixed with the signature chemicals responsible for its bright colors. The explosion of the firework produces gases, and their electrons are excited. As they return to their ground state, they emit colored light, or photons, according to the chemicals used. Blues from copper compounds, yellows from sulfur, green from barium, and so on. Purple can be created by using strontium together with the blues of copper. For each substance, there are specific energy differences between the excited state and the ground state that are predetermined. The wavelength, and so the color of light emitted, is fixed by these energy differences, giving each substance a unique line spectrum. The easiest way to explain the reasons why these different colors are produced is because of the architecture of each chemical atom. For example, say we have a strontium atom which would produce a red color. This would be due to the fact that the photons produced from an electron dropping energy levels would match the particular wavelength of the color red. So if we had another atom which was within the same range of strontium, then we would also expect the color of the molecule when reacting to be red. Let's break down what these color-producing compounds are made up of: color producers and chlorine donors. Color producers are the actual metals themselves, and where the base color derives from. Chlorine donors, on the other hand, aren't the colors themselves, but instead enrich and intensify the color producers. There's a long list of these different compounds, but generally it is broken down into 6 categories, or pure substances, and 2 mixtures. Strontium salts, calcium salts, sodium salts, barium salts, copper salts, metals, and mixtures to produce silver and purple.
Hello.
So in fireworks, you would usually start with an oxidizer and a fuel. Then after, you would add the coloring agent that you want. In one case, the oxidizer would be perchlorate 5, the fuel would be charcoal and aluminum, and the coloring agent would be barium carbonate, copper 3 oxide, and strontium carbonate. There are 2 oxidation reactions which show a perchlorate ion is donating oxygens to carbon and aluminum, turning itself into a carbon ion in the process. The coloring agents are added after because they produce colorful ions and aren't in the reaction because they aren't getting oxidized. However, after these 2 oxidation reactions occur and all 3 coloring agents are added, the firework, or flame in this case, would look like this.
You shall not pass!
Colored fireworks have been around since the 1830s and are used by nearly every country to celebrate holidays that mean a lot to some people. However, only recently have we discovered the many harmful effects that could be caused by them. It would make a lot of sense considering the fact that when these fireworks explode, they shower their surroundings with thousands of metal flakes and pollutants. Over time, some of these pollutants might degrade, but others won't. With the help of chemistry, cities like Sydney have managed to create 100% biodegradable fireworks, and hopefully leads the way for future displays.